Hi, let us talk about queue data structure. Queue data structure is also known as FIFO. First in, first out. Whatever items come first, they are removed first. Let's see this example. Here we have a queue with these items 10, 15, 20, 30, 40. 10 must have entered first, then 15, then 20, then 30, then 40. Now if we try to add an item, we will be adding here. Right? So if I add an item 50, it will be added here. And if I want to remove an item, the item which was added first will be removed first. Right? So 10 will be removed. Then if I remove next item 15, then next item 20, then 30, then 40. So 50, if I want to remove, it will be removed after all these items are removed. We may also consider queue as a pipe in a supply chain. In a supply chain, you try to push some items at one end of the pipe and you try to remove items from the other end of the pipe. So it's like this, items are going to be added one by one from this end and they are going to be removed from this end. So that's how queue data structure works. This end of the queue is called front and the removal operation that we do from this end is called DQ operation. And the addition operation that we do at this end is called NQ operation. So if I want to add an item 50, I'll be doing NQ50. And if I want to remove the item, I'll be calling DQ and DQ will remove this item 10. And once you remove this item 10, your next item 15 will become front of the queue. And once you add an item 50, your new item will become rear of the queue, right? This end is front and this end is rear. So first item which is going to be removed next is called front item. The item which has been just added is called rear item. So we have operations like get front and get rear also. If I call get front, I'll get the item 10. If I call get rear, I'll get the item 40. We have other operations like size and is empty. Size for this queue is going to give you the output as 5. There are 5 items in the queue right now. Is empty simply returns a boolean value. It returns true if the queue is empty. It returns false if the queue is not empty. So if you see this queue example, this is not empty and is empty function is going to give you output as false. Let us now get an idea about the operations on queue with this example pseudocode. So this code is language independent. Here I am first creating an empty queue. I am assuming that syntax is for creating empty queue. Then I am enqueuing certain items. I am enqueuing 10, 20, 30, 40. So when you do the first enqueue operation, your queue has only one item, 10, and this is both front and rear. If you call get front now, you will get 10, and if you call get rear, you will get 10. Now we enqueue 20, so 20 goes here and this becomes your rear and this is your front. Now when you enqueue 30, 30 is inserted at the rear and 30 becomes the new rear and 10 is your front, 10 remains front. So front is going to change only when you DQ an item and rear is going to change only when you NQ an item. Now 40 is being enqueued, so 40 will be enqueued at the end and only rear will be changed and 40 will become your new rear. Now when you call DQ operation, 10 will be removed from the queue and your queue will become 20, 30, 40. And you can notice front is changed now. Earlier front was 10, now front is 20. Now if you call DQ operation again, 20 will be removed now and 30 will be your new front. Rear is not changed by the DQ operation. Rear has been 40, 40, 40, right? Now when we call get front, you will get the output as 30. Front item is 30. Now if you call get rear, you will get the output as 40. So if you implement this pseudocode in any programming language, you will get the output as DQ will give you 10, this DQ will give you 20, this get front will give you 30 and this get rear will get you 40.